Welcome to another Unnecessary Computer Things. Today we're going to be racing a VIC-20 running BASIC versus a VIC-20 running C code compiled with the cc65 compiler. So first let's get a listing of what we're actually going to be running, and of course the cc65 code has just the syscall to the assembly or the machine language behind it, and then the basic code is a little bit more complicated. So let's actually let the basic code start. Well, let's type run. So okay, so as you can see, the C code's probably about twice as fast. This is probably not a typical case for the C code, just because the float library needed to be added in separately. cc65 doesn't actually support floats natively in C, partly because the target processor doesn't. So there is converting to CBM floats and then doing the operations on actually long integers. So the cc65 float lib actually typecasts or typedefs the floats to longs, and then does all the operations and then calculates them back. So every single operation that has to happen with those longs, and then has to be converted back and forth. Just really quickly, basic code is just the typical basic code. It's limited to 2 letters for identifiers and things like that. But here's the C code. So this VIC-20 comes with a cc65 compiler, but the float and the math headers are actually coming from, I believe, the cc65 float lib. And here's some build instructions here. I'll also have a README markdown. Initially, I was thinking, oh, we're going to use native floats and then convert, but it doesn't work like that at all. So that's part of the joy. Couple things I've noticed with the cc65. One is that every compiled program toggles things from uppercase in graphics to lowercase uppercase. So this is actually calling the character out routine with the character that actually switches it back. So there's a graphics function I set up, and then the clear screen function I set up. One of the other challenges with programming in C is that you don't actually have the pet keyboard to output those characters, so that's fun. And then this is meant to almost exactly replicate the basic program. This is stuff you probably wouldn't actually do in real life modern C, but this is like grabbing a memory location and casting it to a chart pointer, and then actually setting that dereference. And then here's graphics in clear. So the most challenging part for getting this actually correct. So these floats are typedefs, as I said. They're typedef to long. But that also means so every operation you have has to go through one of these these specialized functions. So if you're using an integer as a float, well, those formats are actually different bitwise. So you actually have to do an I to F on it to convert it to the fake float format. And then fmul, so every float multiplication has to be going through here because if you did a straight integer multiplication or straight, well, it would be straight integer multiplication, and that would actually botch your format. Same with adds. Um, Basically, anything that's a float operation has to go through here. And then uh, because we're still operating on offsets for poking screen locations, if you actually have partial values here, like fractional values here, then it'll actually skew it. So we're actually converting them back to integers. So we're truncating them. The char 81, fun story with that is that I initially had uppercase Q in this location, which does actually present that same circle, but it actually presents it in reverse. And I thought I was actually setting the colors wrong, so that took a bit of debugging. But it's actually pesky 81 that you're looking for there. And we can go through the basic version of this. So this is one of the old versions of my basic code where I didn't actually realize that it ignored these anything after the first two characters. I've discovered that after I tried to reuse define variables in the basic interpreter. So like st is for I can't remember, but then you have po is will overlap with the potentiometer, the paddle function. So you can't use po as a variable or anything that starts with that, and then also poke. But po is the one that overlaps because it's actually like an identifier, not a command. So this is a little bit slower than it would be, probably about 5% slower because I'm actually using 5 character variable names. Commodore BASIC will allow you to use 5 character variable names, but if you overlap the first 2 characters on 2 variable names, you're actually assigning to the same variable. And then I'll have this in the GitHub repo, but so this is a few notes here on you have to build a float lib and get that from GitHub. Somebody was brilliant enough to actually piece that together and get that working. I think it's pretty well complete. There are a couple little glitches, like if you, depending on what target platform you're on, you'll run into some errors with the float test. The best indication is that's just priority of what the C compiler is, the native C compiler is trying to find versus what cc65 is trying to find. We'll try to find later. So it's trying to find the math library, and then those functions aren't there in that case. So and then some instructions. So when Vice has a file menu and you do smart attach, and it just automatically starts. If you are on, I think, GTK Vice or Mac, you do an auto start tape image, and switch file editor filter to all files, and then you also need to hit auto start or it won't actually run the first time. All right, that's all I wanted to demonstrate today. Thanks for watching.